So let's calculate the greatest common divisor of these two. These are the polynomials. We had this example before, which end up to a crazy division. I mean, the coefficients became crazy fractions, okay, in dividing this a by b. Okay, now let's calculate it using the two linear combinations like the previous example. Here the degree of this is 6 and this is 4. So if you multiply a by any number and this by any number, this still is there and this also. So we could not get rid of this, but if we add these two, we could get rid of 6x plus 2. The term of the degree of 1 and the constant term. And the resulting polynomial would be still of the degree of 6, but would not contain the constant term and the x term. So it would be something like that: x squared plus some number times x squared. Let's not write it, but a m times x squared and m times x cubed plus 2 h times x to the 6. Okay, and we could write it as, we could take x squared outside, and that would be m plus nx plus h x to the 4. Since this is a linear combination of a and b, so a and b does not have such a factor, so this inside the parentheses should contain all of the common factors of a and b, and the greatest common divisor of this inside the parentheses, and a equals to the greatest common divisor of this, and b also the greatest common divisor of a and b. Okay, so let's do the addition by the fast method. First, write down the coefficients of a: 1, minus 4, minus 3, 16, 7, minus 6, minus 2. Also the coefficients of b: 2, 6, minus 1, minus 6, and 2. Okay, this is a and b. Let's call that c. A plus b. C would be, and inside the parentheses, I just explained, we call that c, which is a plus b over x squared. Okay, So that would be this to 0, 0, 0, 6, 10, minus 1, minus 4, and 1. And now since inside the parentheses is of the degree of 4, so let's write them here: 6, 10, minus 1, minus 4, and 1. Okay, this is B. And let's have another polynomial of the degree of 4 by multiplying C by 2 and subtracting from B. You know, this becomes 2, and after subtracting, the x to the 4 term would go away. So this is 2C minus B. Let's first, let's first write down, calculate the coefficients of 2C. 2C, 12, 20, minus 2, minus 8, and 2. Okay, and subtract this from B. So we don't need that anymore. Let's write it here. This is 2C minus B. No, this is B minus 2C. We're gonna subtract this from this. B minus 2C. Okay, let's start by this. 2 minus 2, 0. This minus this 2. This minus this 1. No, yes, 1. And this minus this, minus 14. And this minus this, minus 10. Okay. So this is of the degree of 3. And let's have another polynomial of the degree of 3 by multiplying this by 3. The constant term of B becomes 6, and then we could subtract it from C. So we could get rid of the constant terms. Let's don't need it. So let's write down here. Now I think let's write down the coefficients of 3b here. 3b would be 6, 18 minus 3 minus 18 in this 6 and 3b minus c would be 0 here, 8, this minus this, minus 2, this minus this, minus 14, and 5 here. So, you know, this is still of the degree of 4, but since it doesn't contain the constant term, so we could take out x and write it as a product of x and another polynomial of the degree of 3, which, you know, again inside the parentheses contains all the common factors of a and b and the greatest common factor of it, of the inside polynomial of both of them equals to the greatest common factor of a and b, or, you know, the greatest common factor of inside the parentheses of every linear combination is also equals to that. Also, every linear combination divided by powers of x, like this. So, let's write it down this way. 8 here, shift them, minus 2 here, minus 14, and 5 here.